Good morning, students. So we discussed the last class. So that topic is what is the stress, what is the strain, and how many types of different type of the strain and or stress. So now today discuss about the topic is modulus of elasticity, modulus of elasticity. So modulus of elasticity means so the stress. STRESS, stress is directly proportional to the strain. Okay, stress is directly proportional to the strain. That is the Hooke's law. Okay, Hooke's law. So Hooke's law means so he have taken, so this is called as the stress, and he have produced the strain. So stress is increased. Okay, stress is increased. So corresponding to the strain will be produced in the wire. Okay, along the length of the wire. So that means. Okay, obey the Hooke's law. Within the elastic limit, the stress is directly proportional to the strain. Stress is directly proportional to the strain. Is called as a that is the Hooke's law. Okay. So according to Hooke's law, the stress is directly proportional to the strain. That means, so the proportional can be neglected, that taken the stress is equal to E into strain. So E is equal to stress by strain. Stress by strain. E is called as a modulus. Okay, modulus, elasticity modulus. E is called elasticity modulus. That is means. So elasticity modulus means the ratio between stress to strain. The ratio between stress to strain is called as a elasticity modulus. So that modulus divided or classified in three types. Okay, so that is called as a Young modulus. Okay, one is the Young modulus, and another is bulk modulus. Okay, now third one is shearing modulus. Okay, so Young modulus, bulk modulus, shearing modulus. So what is the Young modulus? So that is means Young modulus within the elastic limit. The stress is the longitudinal stress divided by longitudinal strain. Longitudinal stress by longitudinal strain. Okay, longitudinal stress to longitudinal strain is called as a modulus. That is called as a Young modulus. Young modulus means within the elastic limit. Okay, the ratio longitudinal stress to longitudinal strain is called as a Young modulus. So that is equal F by A. Okay, F by A is nothing but longitudinal stress. Longitudinal strain is nothing but so something changed by original length is called as a Young modulus. So we can write FL by AE. Young modulus Y is equal to FL by AE. That is called as a Young modulus. Now, so another taken bulk modulus. What mean bulk modulus? So already bulk stress by bulk strain. Bulk strain is called as a bulk modulus. Bulk modulus means bulk stress by bulk strain is called as a bulk modulus. So bulk stress, that is nothing but F by A. Bulk strain or volume strain. Okay, so volume strain minus delta V by V. So F V by A into delta L. Okay, delta V. So minus taken, decreasing volume. Okay, so that is called as a bulk modulus. Now another one So the shearing modulus S is equal, okay, that is the shearing stress shearing strain is called as a shearing modulus. So F by A by theta. So that is good. F by A theta we can write. Okay. So the shearing modulus means so that is called as a shearing stress by shearing strain is called as a shearing modulus. Okay. So what is the Young modulus and bulk modulus and shear modulus? Very important topic. Okay, got it. Now discuss the another topic that is called as a strain energy or potential energy. Strain energy means, what is the strain energy? The work done against the interatomic forces is stored in the form of elastic potential energy. Okay, that is called as a strain energy. Strain energy means work done against means opposite. Okay, against interatomic forces. Okay, inside interatomic forces stored in the form of elastic potential energy. That work is called as a strain energy. And so expression for strain energy or elastic potential energy. Okay, so expression for strain energy or elastic potential energy. Now take a wire. Okay, the wire is fixed one end, another end is free. Okay, so the length of the wire is taken L, area of cross section is taken A. Okay, the wire of area of cross section is A, and so the length is taken, that is the length L. Okay, now some external force, the deforming force. Okay, some deforming force will be applied along the length of the wire. Okay, some extension will be developed, some extension will be produced. Okay, so extension or elevation, that is the small extension D will be considered. Okay. Now, first of all, we consider the length of the wire is taken L and area of cross section is A. Okay, so fixed is one end, another end is free. The deforming force will be applied along the length of the wire. Some extension will be produced in the wire. Got it? Some extension will be produced in the wire. There is a small extension is taken, that is the D. Total extension is taken E. Okay, now total extension taken E up to now. Okay, so total extension E, small extension is D. So small extension D according to work done, small work done. So dW is equal F dot DE is taken. So small extension, small work done. So small work done is equal to force into displacement, force into extension. Okay, we are consider the small work done dW. Small work done dW. So dW is equal F dot DE. Okay, got it. So now total work done. Now to find out the total work done up to 0 to E, total elevation is taken, total extension. Okay, total extension 0 to E. Okay, up, that means the total work done W is equal to integration. That line is called as the integration. So integration are introduced in the maths in intermediate level. So this is called as the integration. So integration is taken. That is called as this is called as the integration. So integration, that means the total construct. So f dw. So integration dw. So the total work done, integration of dw. So the total work done is taken 0 to e is the taken limits. Okay, 0 to e is the limits. 0 to e integration of dw is taken total work done. Total work done. Got it? So 0 to e is called as that is the limits. Limits. So integration of dw is get total work done. We get total work done. Okay. So that means integration of 0 to e dw. So dw already to find out f d. Okay. F d. So what is the F means? F is means deforming force. So that means Young modulus is equal to F by A by E by L. Okay. So F by L A D. Okay. Cross multiplication, that is the F is equal Y A E by L. Okay. So Y is equal to F by A E by L. So F L by A E. So cross multiplication taken. So F is equal to A into E into Y by L taken. That is called as a force. So the force value substituting in the equation. So 0 to E. F means already to find out Y A E by L D E. Okay, so Y is the Young modulus is constant, area is constant, L is also constant. So the constant terms taken outside. So by L, so remaining integration of 0 to E dE. Okay, so that is one of the formula. Okay, so integration of x to the power of n dx is equal. Integration of x to the power of n dx is equal x to the power of n plus 1 by n plus 1, x to the power of n plus 1 by n plus 1. Okay, so e to the power of is taken 1. Okay, e to the power of 1 means x to the power of n dx, x to the power of n plus 1. So that we can write in a denominator, so n plus 1. So similar pattern here also like that. Here observe, that is y a L. So integration e to the power of 1 d e to the power of 1 plus 1 by 1 plus 1, because here n plus 1 by n plus 1. Here taken 1 plus 1 by 1 plus 1. Got it? Now, so the limits is taken outside after integration. After integration, the limits is goes to outside. So 0 e. So now taken, that is the w is equal. So w is equal y a l. So e to the power of square by 2 0 to e. Now substituting the limits inside. So y a l. Limits are substituting. So limits g substituting e plus. Okay. So e place lo substitute here. So that means so e plus lo substituting e square minus 0 substituting 0 square. Okay. So the 2 is taken outside. Okay. So one is the upper limit substituting minus lower limit substituting. Got it? Upper limit substituting e plus lo substituting. Okay, so minus 0 substituting. That means e plus lo substituting e square minus 0 square. Okay, we get, so final equation y a e square by 2l. Okay, got it? E square by 2L. Okay. Right. So now take an equation. So this is called as the total work done. So work done is equal to Y A E square by 2L. Okay. So multiplication and dividing with respect to L. Okay. So W is equal to Y is taken Y. Okay, or is taken, that means E square, okay, E square by L square. Okay, right. So 1 by 2 we can write side. So remaining Y is taken, E square, L into L square. So remaining A into L. A into L. So the total equation divided in the parts. So Y is taken, Modulus like it separated. So E square by L square we can write. Remaining terms A into L. So that is the W is equal to, okay, W is equal of Modulus. Modulus means stress by strain. Stress by strain. Okay, got it. E square by L square. Okay, E square by L square means E by L is called as a strain. Change in the length by original length is called as a strain. Okay, strain square into A into L. A into area, L into length. Area into length is called as a volume. Okay, so volume we consider. Okay, strain are cancelled. So remaining equation we get of stress into strain into volume, of stress into strain into volume. Okay, so this total work done will be stored as a potential energy. The total work done U is equal to, okay, stored as a potential energy. So the potential energy of into stress into strain into volume. Okay, got it. So according to the definition, expression for strain energy and elastic potential energy. So the potential energy, that means the total work done stored as a in potential energy. So U is equal of stress into strain into volume. Now consider 1 unit volume. 1 unit volume is means, so is taken volume. So volume is cancelled. So remaining equation U is equal of into stress into strain, of into stress into strain. That is called as a. Now consider the volume is 1 unit. Okay, so consider the volume is 1 unit. So that is the potential energy. Okay, elastic potential energy U is equal of into stress into strain. Okay, got it. So now discuss the another topic. So next class. Okay, thank you students.